know a lot about, or that I am, sorry, I'm moving around so much. My stand is quite literally a trash can on a top hat on him. My head's right here with the mic. That's the best I got, so we're gonna work with it. Alright, so for now today, we're gonna be talking, god damn, my hair looks terrible. We're gonna be talking about how stars form and the basic form of stars. So first, we have these nebulas or gas in space. They are typically around 1,000 to 10 million times the size, or not size, well, mass or weight of our sun. And typically, and this gas is cold, like it's really, really cold. Like, what else do you expect? It's in deep space, is basically almost zero. And this coldness causes the glass to clump together and do like lots of clusters and clumps and stuff. And eventually this matter collapses into a baby star. That's what happened to our sun. In fact, that's how us right here, right in the flesh, got created. So yeah, these stars usually use fusion as their power source. So like they would fuse elements like, I'm pretty sure, hydrogen stuff, like atoms, into hydrogen for billions of years. Like say our sun right now is doing that right as we speak right now. Maybe you can't see because it's nice. Sorry for terrible lighting too. I quite literally have nothing else better. This is the most ghetto setup out there, but hey, we're making do with it. So yeah. Anyways, back on topic. I guess I tried usually on the stars that fuse that way will eventually run out of resource. Main sequence stars like our sun typically run out of that in around 10 billion years. So we still got time. Well, only around 1 billion years, because when these stars run out, they start like a main sequence star or the sun, and they tend to end up fusing heavier elements like helium, which causes, I'm pretty sure, causes the core to not be able to produce as much energy as before, so the outside starts crumbling on into it. Crumbling on, I'm sorry, stay up there, I put the camera here, but I guess I should stay right at the screen, so it typically causes them to, shimmer, oh god, the shimmering of my screen, oh no, that's the weakness, so I guess I might, there you go, basically better. So yeah, this ends up causing the star crumbling down. Well, actually, first, when it exhausts the first hydrogen fuel, fuse to hydrogen, it crumbles down on it because it has lack of energy. So the core starts making or fusing heavier and heavier elements. Our main sequence star, sun, is only gonna fuse up the helium and cause the outer layers to swell hundreds of times, which would eventually turn into a red giant. Now, that's gonna happen to our sun. It's gonna swell up to Earth's orbit, possibly, but most likely swallowing it, and then turning into something, its core, what remains of its core, which is a white dwarf about the size of the Earth. But it's significantly more massive and significantly more hot. Because, well, it's the remnants of the core of the sun, so of course it's gonna be hot. But stars that are more massive, like around 15 times more massive than our, I guess that works. That works great. that works great here, I guess. They ended up forming, well, 15 times the size of our sun. When they fuse other elements, they fused even heavier elements, like helium to different one. I forgot all of them. I'm pretty sure some into magnesium and stuff, but the final stage is iron. So from silicon, which is like one of the second to last stages, into iron. Iron, nuclear reactor. You can't fuse anything with that. You can't fuse. So what happens when the iron core, when the iron core of that massive star is formed, it can't fuse. No more energy, no fusion, no energy, which means all the weight of the star crumbles down. As I mentioned, when it was fusing elements, it was swelling too, just like we would with our sun. It's like with our sun. I hope you can hear me. I'm pretty sure you can hear me, but yeah. With our sun, so that ends up. So yeah, it swells really big, like a red supergiant. In fact, that's what the largest star, Stephenson 18, is right now. neutron star, but you're seeing both its front and the back of it because the light bends around it. So, say you're right here and here. This is a neutron star. This is right here. The light from the back side bends around and you're here. Both front and back. That's why in a black hole, the black hole forms when the crushing matter isn't strong enough to form an infinite mass. Point singularity. Doesn't work for reality. Because let's be honest, a lot of stuff doesn't work with our current calculations of math. Look at quantum mechanics. And what does the answer quantum mechanics? Pretty sure it's not lying, pretty sure. But yeah, and then the black hole went around it and formed an accretion disk because the gas that's around. Like I thought, a gas would be in the black hole or outside. Okay. But yeah, but if a black hole, let's say option B, it already all got sucked in the black hole. If it's near a star, it'll start ripping all the light and mass off the star. Make a really cool like effect, like spaghettification. That's why there's getting too close to a black hole, by the way. Spaghettification, which ends up forming the accretion disk. And the reason why it's not just a flat disk, disk around the black hole. Same reason why neutron stars, the back light from the black hole warps around it. You can see it's like a little bump here. It's like a bump here, bump, because it's warping the other side. Like these creatures right here. It's warping around the black hole into your eyes. Pretty cool. Unless you're near it, you'll probably get ripped apart. Spaghettification. Let's go back to neutron stars. But so neutron stars, there's actually a rare type neutron star, rare, called pulsars. And what they do, spin fast. Magnetic jets go pew. Pretty much, if it's a pulsar in the solar system, like let's say magically, poof, out of nowhere. Pulsar, we become, straight up, we have gamma radiation raining down on Earth, cooking everything alive. Pulsars can spin up like 6 in a time per second, I'm pretty sure. But we also have magazars, which is a type of neutron star too, when they're just formed, where they're magnetic. Magnetic sphere, like the weird energy field, like I'm pretty sure it's called a magnetic field. Yeah, magnetic field where it helps deflect energy from the sun to the poles. Yeah, that. But imagine that Earth, but around 100 billion times stronger. Yeah, you get in that, you're cooked straight up. Like I'm not even playing like you were gonna get cooked inside out from that. But we should talk about what happens afterwards. Let's say for a sun, it continues to swell. It swells to the size of Earth's orbit, then suddenly pushes away the outer layers and melts away into like a gas that forms a planetary nebula, which then repeats the same cycle from birth to other courses. Yeah, this video is not that long, but and again, this is my birth video, so yeah, I'm definitely gonna do some ASMR gaming though. Oh man, let me see if I can figure out how to record on that. I'm gonna figure it out, but I'm also gonna do history and biology. It's inspired by a single ASMR creator. I don't know why, but hey, I think I'm finally doing something else. So, yeah, see you later. See you later. I'm gonna see you later. Goodbye. This is my first video of rock ASMR. See you later.